This problem says that the number of bacteria, P of H, given by the function P of H, in a certain population increases according to the following function, where time H is measured in hours. And we have this exponential function that says P of H is equal to 1,800 times e raised to the power of 0.19h. So an exponential growth formula, or exponential growth function rather. We want to know how many hours will it take for the number of bacteria to reach 2,400. Round your answer to the nearest tenth. So in other words, what we're asked to do is to solve this equation. 2,400 equals 1,800 times e to the power of 0.19h. Solve that equation for h. Now, the variable that we are looking for happens to be in the exponent of e. And so I want to show you a way that we can solve that using a graphing calculator. And I use Desmos again in this case. And what we do is we define, first of all, P of H to be 1,800 times e to the power of 0.19 times h. And that will graph the function. Now, we can't see it because of the window. The function is multiplied by 1,800, so I need to hold in shift and drag down my y-axis to get my function to fit, and there it is. Now I'm going to define another function just to be the other number that I'm looking for, 2,400. And so what does that give me? That gives me the intersection between the original given function, P of H equals 1,800 times e to the 0.19 times h, and the number 2,400. So finding out where those two functions, 2,400 is a function, it's a horizontal line, finding out where they intersect is going to give me the solution. It's going to tell me for what h can I plug in up here, will I get 2,400? And that's given to us right here, where the ordered pairs here are an h value and a p of h value. So the answer that I'm looking for, rounding to the nearest tenth, is h is equal to 1.5. And so that is the answer. In other words, that's how many hours it will take these bacteria to grow to a population of 2,400.